Hello everyone, welcome back to my channel. So in today's lesson we are going to talk about automata theorem. As our previous video we have already treated this topic, but we solve just one problem. So I thought it fit that it's an opportunity for me today to just try to solve some other problems that I think they are very beneficial. So here, as you can see, we have two problems on the board. The first one here has already a diagram. So based on this diagram, on our previous lesson, we only treat about binaries, that is zeros and one. But in today's lesson, we want to treat both binary for this one, and this other one is alpha. We use alphabets. So here you can see here we have our transition here from Q0 to Q2. Our transition is B. From Q1 here, Q1 is our initial stage here, Q1. So also you can also change this one. You can either say Q0 starts from here. Here you can say Q1, Q2. But for us here, we say Q1 is our initial point. So now we want to solve this problem to see if these string given here on the board are accepted by the machine or not. As you know, automata theory has to do with language translator. So this one here we can just try to solve if we input this string on the machine, it will accept or not. So first, for a machine to accept this language, first the final state has to be Q2. So if you come here from Q1 to Q0, since this Q0 is not your final state, then it will not accept. So in order for the machine to accept this language, your final state needs to be Q2. Irrespective of the initial state, your final state is supposed to be Q2. You can either start from Q2, you end Q2 again, then as you can see, this has double circles to tell you that this one is our final state. And this is the initial state, as you can see, is Q1. So you can see the arrow pointing towards this Q1 means this is the initial state. So also the other problem here on the board says, construct the DFA, which is deterministic finite automata, for the language ends with a string that ends with 0, 0 over binary numbers, that is zeros and one. So you can see here on the board, this one of course, it will accept by the machine because it ends with 0, 0. So now we are going to see if this one is also accepted by the machine, means our solution is not correct. Okay, so now we are going to solve these two problems on the board and see which one conform to this automata theorem, and we'll see based on our solutions. So now let's see here. The first one says, but again, before you try to start to solve this one, we need to draw a table, which is referred to as transition table. So our transition table looks like this. We are going to use all the states used here and the inputs. Our inputs here in this diagram is A and B. That's our inputs. Our states are Q0, Q1, and Q2. So now we draw this first, our table, transition table. So from this transition table, we have 3 points. So you can say here, this is your inputs. Inputs, these are our states. So now we can start here. The arrow, which is Q1. You can use Q1, then Q2. You can use Q0, Q1, Q0, and you say this is Q2. Mind you, for Q2, you can either use double circles or you give an asterisk. So here, let's give an asterisk. Okay. So now, what about our inputs? Our inputs are A and B. So here we say A and B. So now let's see. So based on this problem we have on the board here, now we are going to solve this. We are going to solve this problem based on our transition table. This is transition table. Transition table. So now let's see. Q1A is what? We'll check from here. Q1A is Q0. Q1A, you can see the arrow here. Q1A is Q0. Therefore, our Q1A here is Q0. Q0. Then this Q1B, Q1B is Q2. So Q1B is Q2. Then again, come here, Q0A. Q0A is the same Q0. Q0A, as you can see the transition, Q0 just go to itself. Q0A is the same Q0. So here we can say Q0. Q0. Then Q0B. Q0B is Q2. Q2. Then we come to Q2 here. Q2A. Q2A is Q2A is Q2. Q2 and Q2B is the same Q2. Q2. So now we are going to solve now this problem based on this transition table. These two problems we are going to solve based on this transition table. So let's see here. So the first one says it has a string A, B, A, B. And the second one here has a string of A, A, B, A, B, A. So for this first one, first we can do our transition. We can do our transition here. Then we give our string here, which is A, Q, because our initial state here is Q1, so we say Q1, comma, AB, AB. Q1, comma, say AB, AB. So now we are going to solve this problem based on this one. So let's see. So now first, here, we can take first this first string, which is A. We can say Q1, comma, A. Then we give B, A, B. B, A, B. So now we come to our transition table here. Let's use this red marker, is better. So now the transition Q1, this Q1A, Q1A is Q0. So here we can say this is Q0. The whole of this is Q0 now. Okay, we say comma B, A, B. Okay, so now we take this one again, Q0 and B. So again, the transition of this Q0, comma B, and we say AB. So Q0 B, Q0 B is Q2, Q0 B is Q2. So this again we say Q2, comma AB. As you know, the whole of this now is this Q2, the whole of this is Q0, and this one AB. So then again transition again here is Q2, comma A and B. So Q2A is Q2. So this Q2A, let's use here, Q2 transition Q2A is Q2, comma B. That is, this is Q2, comma, B. So Q2B now is what? Q2B is Q2. Therefore, as you can see here, this is our final answer, which is Q2. So if this Q2 is what the end of the transition, as you can see here, this is the end of the transition, means this is a finite automata. Okay? So therefore, we can say this transition, that Q2 is a finite automata. Q2 is a finite automata and hence is accepted. Is accepted. Then again, we'll come to the second part. The second part, let's solve it here and later we can just efface. So the second part says A, B, A, B, A. A, A, B, A, B, A. So Roman 2, this says A, A, B, A, B, A. A, A, B, A, B, A. So now, again, we'll start with our transition. Start with our transition here. We say transition of this from Q1, comma, then our string A, B, A, B, A. A, B, A. So let's see. This again, we take this first one, then we say our transition from Q1A, then we say A, B, A. So Q1A, from this table, Q1A is Q0. This is Q0, comma, A, B, A. Q0A is Q0. Okay, so now we take this one again, Q0A again. Q0A, B, A. Q0A. This Q0A again is what? Q0A is just Q0 again. Q0, comma, B, A. So now we take Q0B. Q0B, A. So then Q0B here, Q0B is Q2. We say transition is Q2, comma, A, B. Then again, Q0A, comma, A, and we say B, A. Q0A is Q0. Q0, comma, B, A. Then Q0B. Q0B here. Q0B is Q2. Use here. Q0B. Q2, comma, A. Then finally, Q2A now. Q2A is Q2. Q2A is Q2. Therefore, this one, Q2 is a finite automata. It's a finite automata, and hence this one again, because Q2 is our final state. Here you can see is our final state. So irrespective of what string you use. If your final state is this given on your transition table, then it's accepted by the machine. So therefore, this is accepted. This is accepted. So now you can see this one is different. This one is different from this one we are going to solve. But first, let's try to utilize this space. We try to enface here and try to solve the other problem. So now let's see. This other problem says construct this DFA for the language. The string ends with 0, 0 over 0, 1. This one is binary. So now we have two problems on the board here. So we are in this one satisfies this one. So when we solve this problem, this one must be accepted by the machine and this one is supposed to be rejected. But if this is accepted, it means we are wrong, okay? So now let's solve. But first, we need to construct this DFA, deterministic finite automata. So we'll start by drawing. We said here Q naught. You can draw any diagram you want, only that you need to end with 0, 0. That's the only condition. You can use Q naught as your initial state, or you can use Q naught as your final state, or you can use Q1 as your initial state, or you can use Q2. Irrespective of what you use, your final string is supposed to be or must be 0, 0. Okay? In order for the machine to accept this language. So now we start by drawing this. We say this Q naught, then we say this Q1 and Q2 and Q2 here. So we have three states. So now we need to join these points. Let's say we join this to this. Then this will come to this. Then this to this. And let's say this one again. Then this, let's say again, can give. Yeah. So, okay, Q2, Q1, this one again. Okay. So let's see. Here we can say 0. This again we can say 0, 0. Here let's say we say 1. Here this let's say 1. And this we can say 1. Okay. So let's see. So first, let's say our final state is. Let's say our final state is this Q2. Okay, then Q naught is our initial state. So that is how we want to solve this problem. 1, 1. So now, what you need to check first, if we start from the initial states here, it's supposed to end Q2 with 0, 0. It's supposed to end Q2 with 0, 0. So of course, this one here, this one needs to have 0, 0, 0, 0 again, 0, 0. Yeah. So if we come here, let's see here, this from Q naught, we say here 0, 0. These are final states. So it's okay. Then again we say 1, 0, 0 is okay. Then again this we say 1, 0, 0 because we have 1 0 here, almost 2 zeros. It's okay. Then this again we say 1, 0, 0. So of course this one is correct, but we don't have like this 0, 1, 1. So if we say here 0, 1, 0, no, it's not accepted. So now let's solve first. Let's take this one. Number 1, 1, 0, 1, 0, 0. And we can do our transition table here. Transition table. Transition table here. These are our inputs, and this here is our states. Now we have here, say Q naught, Q1, and Q2 with string. So now let's come here. Q naught, this is A, 1, 0 and 1. 0 and 1. So now Q naught 0, Q naught 0 is Q1. Q naught 0 is Q1. So this will say Q1. Q naught 1, Q naught 1 is what? Q naught 1 is Q naught. Q naught. Q1 0. Q1 0 is Q2. Q2. Q1 1 is Q1. Q1. Now Q2 0. Q2 0 is Q2. Q2 0 is Q2. Q2 1. Q2 1 here. Let's say you can either remove this or you can also change this here. We say 0, 1. Same, so that we can get our final states. But if you say here 1, 0, 0, no. So let's just leave this blank. So we say 0, leave this as blank. Okay? But the choice is yours. If you want, you can add here 1. But mind you, you need to have 1, 0, 0. So that's the condition. So we need to leave this one as 0, 0 because of the condition here. End with 0, 0. So now let's solve this problem and see. So again, we start from Q naught. So we say Q naught, comma, 1, 0, 1, 0, 0. And now we say Q naught 1, 0, 1, 0, 0. Q naught 1, Q naught 1 is Q naught. So this is say Q naught, comma, 0, 1, 0, 0. So again we say Q naught 0, 1, 0, 0. So this Q naught 0, Q naught 0 is Q1. It's Q1, comma, 1, 0, 0. So Q1 1, Q1 1, 0, 0. Q1 1, Q1 1 is Q1. This is Q1, comma, 0, 0. This is Q1. So now Q1 0, Q1, this transition, Q10, Q10 is Q2, Q2, comma 0, Q20, as you can see here, Q20 is Q2. Therefore, this is a finite state. This is the finite state, okay? So now we can say this transition Q2 is what? A finite state automata. So therefore, this is accepted. So this is accepted because our final state is Q2. Okay? Our final state here is Q2. So therefore, this string on the board 10100, as they said here, constructs a DFA for the language over the string end with 00. So if the string ends with 00, then if we construct a string that ends with 00, it must be accepted by the machine. So that's why when we solve this problem, we see here is accepted by the machine. So now let's see the one for 011. So let's just use this small space here and see. So Roman 2 is 011. So 011 here. So again, let's solve this and see. Q0, comma 011. Q0, 011 here. So this Q0, 0. Q0, 0. Q0, 0 is Q1. So this is Q1, comma 11. So then again we say Q1, 1. Q1, 1 is Q1. This is Q1, comma 1. Q1, 1 is Q1. Then we take this one, 1. Then Q1, 1 again. Q1, 1 again here. Q1, 1 is Q1 again. Therefore, as you can see, this is not a finite automata. It's Q1. This is not a finite automata because our final state here is supposed to be Q2, but what we have here is Q1. So this is not a finite automata. Therefore, it's rejected. So this string here on the board is rejected because our string here is supposed to end with 00, not 11. So basically, you can see this problem on the board. That these are two different types of problem. You can try a different approach and try to solve and see if the string is accepted by the machine or not. Thank you for watching the video. So again, don't forget to subscribe on this channel, like, comment and share. See you on the next lesson.